Okay, in this video, we're going to finish talking about lists by introducing two-dimensional lists or two-dimensional arrays. I guess I should say list here. We're going to talk about tuples, which is our next data structure. And they're pretty straightforward based on lists. And lastly, we'll get a quick section here on Matplotlib, which is one of the many freely available libraries for Python that make it super useful. Okay. So let's start with the idea of a two-dimensional list. Okay, so we know we have our lists can contain anything. Okay, they contain ints, they contain floats, they can contain booleans, they contain strings, whatever you want. Okay. Well, it turns out that they can also contain other lists. Okay. Okay. So what that allows us to do allows us to, in essence, model matrices in math. Okay, so I could do 1, 2, 3, comma, then do 4, 5, 6, comma, then do 7, 8, 9, for example. Okay, there are two of those there. Okay, and that's how people tend to write them, just because it's easier to kind of see the structure. It didn't line up exactly for me. I wonder if I can make it. Yeah, there we go. That lines up a little better. Okay, it's still one line as far as it's concerned in Colab or in Python in general. Okay, so it should be fine. This should actually be down here. Why isn't it let me do that? I don't know. Okay, we cut it there. We put it down in def main. Okay, and then if I were just to print x, okay, it should just print it out like this in one row. Okay, or in one line. So this can be useful for a lot of things. Okay, but it's important to realize that x sub 0, if I print just x sub 0, okay, what I'm going to get is that whole first array. Okay, so all of that is x sub 0. Okay, if I want to get to the first element, it's x sub 0 sub 0. Okay, that gets me to the 1. Okay, so think of them separately. We have this is the first list, second list, third list, and then inside of those lists, there's other things. So if I want to get to 9, that's 0, 1, 2. So it's 2, which we would call the row. It's in the third column, which has the number 2. Okay. It's also in the third, sorry, it's in the third row, also in the third column, which also has the 2. Okay. So if I print that, it's going to give me a 9. Okay, the last one. Okay. So when we're processing these lists, we often want to go and process them all in a sequential fashion. Okay, so we're going to do this with 2 for loops. So let's start for row in range, and you almost always with these, you're going to have, I usually do like a rows column is equal to 3, and a calls is equal to 3. So there are 3 rows and there are 3 columns. So then I can say for row in range rows, okay, and then if I print, I can print row at a time. I can print x sub row, okay. If I do that, it's going to print row, 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 okay. So I can, inside of that, to get to each one, I can say for a call in range calls, okay. And then if I print x row column, okay. So let's see how this is going to go. So it's going to pick up row being 0 here, call being 0 there. So 0, 0, or 1 is the first thing it's going to print. Okay. Then call is going to go to 1 and give us the 2. And then call will go to 3 to get us the sorry, it goes 0, 1, 2. 2 gets us the 3. Then it's done. Then it goes back out and gets a new row. So this should print 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. See if it does. And it does. Okay. Now, often to make it look more like we expect, okay, I can, on this print, if I put that the end, let's do a sep first. Sep. Do I need a sep? No. I just need an end equal blank space. Okay. When I do that, it's going to print everything together. I do need a sep. No, I need there to be a space there. Is that what I want? Yes. So end is equal to space, not a blank. Okay. But if I want to do row at a time, if I put another print here, I'm not done printing the row yet. Okay. But if I move back to there, now I'm done with that and I can just do a print. Okay. If I do that, it's going to give me this. Okay. So this is the way that the two-dimensional lists are going to work. Okay. Other than that, they work exactly like everything else that we've talked about. Okay. So there's some examples in the book of that if you have some questions. Okay. So the next thing we're going to talk about then are called tuples or tuples. I'll probably go back and forth. So I'm not sure there's an official definition of this. Okay. So a tuple looks like a list. It acts like a list in most ways, except that a tuple is immutable. Okay. Immutable meaning we can't change it. Okay. So let's get rid of all this for now. And instead, let's have a list. L is equal to 1, 2, 3, 4, 5. Okay. And then we have a tuple T is equal to. Looks just like that, but has a parentheses. I said before that the punctuation mark is important. Okay. 1, 2, 3, 4, 5. Okay. So I can print out. I can do a loop. So I can say for whatever C in range length of L, print out L sub C. Okay, that should work. And it does. In the same way, I can say, oh, I don't like that it's that close there. Let's make those tabbed over. There we go. In the same way, I can say for C in range length of T, print T sub C. Okay. And it does the same thing twice. So we're good. Okay. That's all the same. I can get to individual elements just like before. Okay. The difference is, okay, so get rid of all this. Again, we've said, let's define it, that lists are mutable, which means I can change individual elements. Okay. So I can say that L sub 0 is equal to 11. Okay. Now if I print L, I'll go ahead while we're at it. Print T. Okay. So now I've changed the first element of my list. Okay. But tuples are immutable. So you cannot change individual elements. Okay. So if I try, if I say T sub 0 equals 11 and run it, I now get a type error. Okay. Again, the tuple object does not support item assignment. Okay. So that's the difference. Okay. So any of the functions, as long as the functions don't change the individual elements, are going to work the same. Okay. So I can say print, for example, 3NT works just fine. Okay. Oh, I didn't change what I was doing wrong. Okay. So it's still that still returns true. Okay. So you can look through the list of functions we talked about before, and any of them that don't change. Okay, so we can't append. Oh, we may be able to append. Let's try that. Let's think about that. Appending is not changing the element. Okay, so what if I say t dot append 6? Okay. Okay, yeah, that's not going to work. Which makes sense. You can't change the tuple at all. Okay, so that doesn't work. But anything that doesn't, the searches work, any of the other things that you want to do. Okay, note that we can, and this confuses people sometimes. I can say t is equal to 2, 4 or 2, 4, 6. Okay, and that's perfectly okay because I'm not changing the list. I'm replacing the tuple. Okay, you can totally replace the tuple, and that's fine. Okay, you just can't change individual elements of it. Okay, so why would you ever want to do that? Well, it's the same reason we have constants. There are times when you want to have data that can't be changed. Okay, and that's where tuples are going to come in. Okay, other than that, they work exactly like lists. Okay, so the last section is something kind of cool. Okay, and it has to do with this Matplotlib. It's one of, again, many, many libraries. Okay, and to use, and this allows us to plot mathematical numbers, plot whatever you want. Okay, so with this, we have to start with an import statement, and this works. If you're doing this in PyCharm, then you're probably going to have to install Matplotlib. It's probably not there. Okay, but in Google Colab, it's already there for us. Okay, so before my I'm do an import. The Matplotlib. It's not math. I know you think it should be Matplotlib dot py plot. Matplotlib has a bunch of stuff, but we want the py plot as plt. Okay. This as plt is just shorthand. You can name it whatever you want, but everybody in the world that I know of names it plt, so people know what you're talking about here. Okay. So in its simplest case, we can just get some x coordinates as a list. And we usually want those in order because these are going to be, we're going to plot points. So we're going to point 0 with the y value, and then 1, then 2, then 3, then 4. Okay. And then for the y coordinates, you can do whatever you want. Okay. So let's say we're going to do 0. So we start at the origin. We're going to do 3, 1, 5, and 2. It's all pretty random stuff. Okay. So on our Cartesian graph, it's going to plot the points 0, 0, 1, 3, 2, 1, 3, 5, and 4, 2. Okay. To make it actually build the plot, we're going to say plt.plot the x coordinates and the y coordinates. Okay. That will create it, but it will not show it. Okay. While we're building, we can go ahead and do a plt.title. Call it sample data, whatever we want to call it. Okay. We can add some labels to this. Okay. So we can say plt.x label. X-axis, we can call it. We do a plt.y label. creatively calling it y-axis. It can be whatever you want. Okay. We can add a grid. Okay. We can do a plt dot grid. Set it to true. Okay. And then to actually make it show, okay, so just to display the line graph, we'll do a plt dot show. Okay, you run this. I didn't make any errors. There we go. There's our points, 0, 0. We've got a 1, 3, 2, 1, 3, 5, and 4, 2. That's exactly what we had up here. Okay. So it turns out there's a lot more you can do with this. Okay. We can do not only line graphs, we can do bar charts, pie charts, all kinds of things. Okay. And we're not going to get into that too much. The book talks a little bit about changing the displays. Then the book talks about a bar chart. So I'll leave that for you to read. It's all fairly straightforward on how you're going to do that. Okay. And then finally, there's a pie chart example in the book. Okay. All work more or less the same way. Okay. So one thing that I like to do with this is that you can create, if you have a function, call this cube that takes some number n. It's going to return n times n times n, or I could have done n star star 3, either one. Okay, that's all it's going to do. Okay, and then when I'm building my plot, when I'm putting my things together here, don't want any of that, don't care, going to keep it simple. So I'm basically plotting a mathematical function. This is y is equal to x squared. Okay, so I want to create this in a loop. Okay, so let's say I want to say for c in range 10. Okay, each time through, I want to I'm creating these x and y coordinates here. Okay, so I'm going to say, I guess up here I need to create my x chords just as a blank list. My y chords also as a blank list. Okay, and then here I'm going to say x chords dot append c. I'm going to add c to the list of that. I'm going to say y chords dot append cube of c. Okay, and then build it like that, display it. So if I do this, you're going to see y is equal to x cubed. Okay, make this more interesting. I could do here, let's say start at negative 10 to 10. Okay, and it will give us this graph. Okay, so we can get pretty complicated kinds of mathematical functions. Whatever we want to do down here. Okay, you can do it. Okay, so if our function is 2n squared, so let's put it down here. So let's say we want to do 2n squared plus 12n minus 10. Okay, then we would just have to say return 2 times n times n. Okay, so n squared, or 2 times n squared, we do it that way, plus 12 times n minus 10. Okay, you can put parentheses if you want. That should be okay. That's what we're going to return. And now when we print that, okay, that's a parabola, and that's what we've created. So 2n squared plus 12n minus 10 will give us this plot. Okay. So lots you can do with that. Okay, so again, today we've talked about two-dimensional arrays or two-dimensional lists, which is a list inside of a list, how to iterate through those. We've talked about tuples, which are another data structure that look just like lists, except you can't change the internal items of those. Okay. And we've talked about Matplotlib, which allows us a nice, easy way to create charts and graphs. Okay.